So write down the topic as thermodynamics. Thermodynamics. Another important topic of physical chemistry. So today we shall discuss about some important thermodynamic terms, because before we start entering into the main topics, we need to understand certain terminologies or certain terms with the help of which we can understand this whole concept. So at first we need to understand that what do we study in thermodynamics. Thermodynamics is the topic that deals with thermo, which comes from thermos. Thermos. Thermos means heat. And dynamics. Dynamics means change. So whenever heat changes are going on in the process, whatever process surrounding us has got heat related changes going on, that is referred to as thermodynamics. So thermodynamics is the branch of science which deals with heat related changes. So it is an important science as it helps. It is an important science as it helps to predict So what are the things that it can help us to predict? Number one, feasibility of a reaction. Feasibility of a reaction. Now, what is the meaning of the term feasibility of a reaction? Feasibility of a reaction stands for whether the reaction will be possible on its own under certain conditions of temperature and pressure. See, it is just like saying that if you just hold something in your hand and if you leave it, so it has the possibility of going down. So that is feasible. Going down is feasible. But if a substance is already present on the ground, so it will not come up on its own. Okay, so until unless it is picked up, so it's not going to come out on its own. So that is non-feasible. So feasible reactions or spontaneous reactions are those reactions which go on their own without any external help. Number two, extent of reaction. How far the reaction will be going on? Extent of reaction. Number three, force that drives the reaction. Force that drives the reaction. And number four, study of heat related changes. Study of heat related changes. So these are some of the important aspects of what we can say as thermodynamics. So thermodynamics helps us to predict and study these particular things. Write it down so that we can proceed further. Can I rub it? Have you done?
Yes, sir.
All of you have done? Can I proceed?
Yes, sir.
Okay.
Yes.
So as I said that today, mainly we will discuss the terminology or certain terms associated with thermodynamics. So what are those terms which are associated with thermodynamics? So first of all, we will talk about system, surroundings, system, surroundings, and universe. System, surroundings, and universe. So what is this system? So when we talk about study of anything, okay, so suppose we are observing a cup of tea. The heat is coming out of the tea. We are observing the cup of tea. So that particular cup of tea will be system for us. That means whatever we are observing, the whole part of the universe, okay, out of the total part of the universe, that part of the universe which is under experimental study, which is under observation, will be referred to as a system. So universe, as you know, is the whole large surroundings to us. So etya dhara, if you are carrying out any experimentation in a small test tube, so that small test tube will be system for you. So system is part of the universe which is under study, and whatever is not included under the system, the rest of the whole of the universe will be called as surroundings. So system aru surrounding log lagi bona universe, and there is an imaginary or physical boundary that separates the system from the surroundings. Now suppose when you are carrying out an experimentation in a test tube, so if it is called that, which is the boundary, then of course the boundary will be the walls of the test tube. Suppose I am staying at home, so the home will be system for me, because whatever I am carrying out, I will be carrying out within my home, and the walls of my home will be the boundary, and the rest of everything in this universe will be called as surroundings. So part of the universe that is under thermodynamic observation, that is under thermodynamic observations, is called the system. While the remaining part of the universe is called the surroundings. While the remaining part of the universe is called the surroundings. System and surroundings together constitute what? What should I write? Together, what do they constitute?
Universe.
Universe.
Together constitute universe. System plus surroundings is equal to universe. The real or imaginary surfaces or lines. The real or imaginary surfaces or lines separating two or more system from surroundings is called the boundary. So the boundary may be visible, may not be visible. And that is why it has been said that it may be real also, or it may be imaginary also. Okay, but what is important is it is separating the system from the surroundings. Are the definitions clear? Boundary, system, surroundings, and universe.
Yes, sir.
Yes, sir.
Okay. Done? Can I proceed?
Yes, sir.
Yes,
Okay,
sir.
fine. So after this, we are going to discuss about types of system. What are the types of system? এনেতো গোটেই পৃথিৱীখনত বহুত কেইটাই system আছে ইউনিভাৰ্সত সব system আমি ইয়াত discuss নকৰো type of thermodynamic systems whatever is required to understand the process of thermodynamics. So types of thermodynamic system. So the system has been further classified into three main types: open system, closed system, and isolated system. Open system, closed system, and isolated system. Now, what exactly is an open system? Suppose we have got an open cup of tea. Now, if you are served with an open cup of tea, so initially you see that it is quite hot, but after some time, if you are not taking it then and there, then what will happen? There will be two changes that you are going to notice. Change number one, the tea is becoming cold. And change number two, a small amount of loss of the quantity of tea occurs. Why? Because water is evaporating out. But that will be negligible loss, but there will be loss. So hence we can say that in open system, there is exchange of both matter as well as energy between the system and the surroundings. Now, when I talk about matter, it means amount of substance. And when we talk about energy, so obviously the heat is getting lower. And that is why in open system, we can say that type of system which involves exchange of both heat and matter between the surroundings. There is no barrier, so it can easily exchange the heat as well as matter with the surroundings. Example, open cup of tea.
Usually the tea is hot. But as I said, that after some time it's going to lower down in temperature, and at the same time there will be decrease in the amount as well because a part of it is getting evaporated. That is why it is referred to as open system. Closed system. So what will be an example of closed system?
Sir, your voice is a bit
In
subdued.
closed system, I will keep the tea in covered cup of tea. Suppose the same open tea cup, if you just cover it up with some lid. Now, when you are covering this tea cup with the lid, what
Sir,
will
your
happen
voice is
to
not clear.
obviously
Sir, your
it will be
voice.
the cup of tea is again becoming cold, though it will take more time, but it is going to get cold after some time, which means that there is exchange of the energy going on. But what will not be exchanged now will be the matter. Matter will not be exchanged, and therefore we can say that type of system which involves exchange of only heat with the surroundings. Only heat with the surroundings, but not the matter. But not the matter is called the surrounding. Is called the closed system. Type of system which involves exchange of only heat with the surroundings, but not the matter. It's called the closed system. So, as for example, closed cup of tea. Closed cup of tea.
Sir, your voice is not clear.
Isolated system. My voice is not clear to you.
No, sir.
No, sir.
No, sir.
Why is it clear or not?
No, sir, it is not coming actually.
Is it not clear?
No, sir.
No, sir.
Just
Neither heat nor matter is exchanged with the surroundings is called an isolated system. So, what will be the example for an isolated system where neither heat nor matter will be exchanged? So, if you keep tea in a thermos flask, so thermos flask is made up of some special type of wall, isn't it? Which does not allow either heat or matter to get exchanged. And that is how we can say that the system, thermodynamic system, can be further subdivided into three types: open system, closed system, and isolated system. Clear or not?
Yes, sir.
Oh, sir.
Okay. Now, after we have discussed the three types of systems, tell me, I'm giving you some examples and you have to think that to which particular system it belongs to. Human being. What kind of system is human being? Is it an open system, closed system, or isolated system?
Open.
It is
Open.
an open system.
Open.
Why? Because human or we people can exchange both heat as well as matter with the surroundings. Okay, so it is obviously an open system. Earth. What is Earth?
Closed.
Open.
No, Earth is also an open system because it can also exchange heat as well as matter with the universe. Okay, so there is no closed barrier in Earth. Can of tomato soup. Can
Closed.
of tomato soup is
Closed.
closed. Yes, can of tomato soup is closed. Ice cube tray filled with water. Ice cube tray filled with water.
Open.
Sir, isolated.
Open.
Ice cube tray is not isolated. How can it be isolated? I'm not talking about kept inside the refrigerator or something like that. Just an ice cube tray.
Open.
It is open. Ice cube tray filled with water is an open system, isn't it? Because I'm just focusing on the ice cube tray, nothing else. Coffee in a thermos flask.
Isolated.
Isolated.
Yes, it is isolated. It's very much clear that the moment we use the term thermos flask, so it has got some special wall which does not allow the exchange of both heat as well as matter. Helium filled in balloon.
Isolated.
Closed.
Isolated.
Closed.
Helium filled in balloon.
Sir, closed.
It
Closed.
is closed. Okay, so it is closed system. ठीक है हो गया? Can I proceed?
Yes, sir.
It is not very difficult for us to understand that in open system there is no barrier for exchange. In closed system there is a barrier only for the matter, not for the heat, and is in isolated system. Obviously, you do not allow the exchange of any of the two. So after discussion of the types of systems, we then talk about macroscopic properties. Macroscopic, as the name implies, macroscopic stands for large quantities. It's not new term to us because in atomic structure we have learned about microscopic particles where de Broglie's hypothesis and Heisenberg's uncertainty principle was applicable. But here we are talking about macroscopic properties. Macro means large, micro means small. So when we talk about the thermodynamic properties which deals with matter in bulk, okay, what is the meaning of the term matter in bulk? Means in large quantities. Whenever we talk about the thermodynamics, it always deals not with a single or double particles, it always deals with bulk, okay, large number of particles, and those particular properties arises because obviously this particular macroscopic properties arises due to the study of all these properties in bulk, in large numbers. So hence we can say that the physical quantities that are used to define the state of a system are called properties. State of a system are called properties. The physical quantities that are used to define the state of a system are called properties. Thermodynamics deals with matter in bulk, in large quantities. So thermodynamics deals with matter in bulk and the properties arises due to the bulk behavior of matter and is called macroscopic properties. So here we are not saying about large size. Here we are talking about large quantity. So whenever we talk about thermodynamic properties, as it has been said that we never talk about single particle or less number of particles. We always talk about in bulks, in large numbers. And because of the topic related to large numbers, so we call the properties as macroscopic properties. So it's not property of a single entity, but it is always property of large numbers. And they are further subdivided macroscopic properties are further subdivided into two types. One of them is called intensive properties and the other is called extensive properties. Intensive properties and extensive properties. So we shall discuss about them in details now. First, you write down up to this much. Intensive properties and extensive properties.
So then,
Can I proceed further?
yes, sir.
Okay. So now we talk about intensive and extensive properties. So these are the properties which you need to understand, because sometimes in the exam it is asked certain properties are given and we need to pick out that which is intensive and which is extensive properties. So before that we need to understand that what exactly are intensive and extensive properties. Now, intensive properties are those properties which do not depend upon amount of substance. Okay, they do not depend upon amount or quantity of substance. Say, for example, if you consider a small piece of glass, and if you take the large piece of the same glass, so there are some properties which depend upon the amount or quantity. Suppose if I ask you, will the masses of these two pieces be same or will be different? So obviously the answer will be, it will be different, because mass, volume, these are the things which depend upon the amount, isn't it? So if the amount increases, mass will increase, volume will increase. But there are certain properties which do not depend upon amount. It is independent of the amount of the substance. So it depends upon the nature of the substance. So if it is asked that what is the refractive index? The refractive index is associated with glasses, and it does not depend upon how much glass you are taking. So obviously it will remain the same no matter whether you are taking a small piece of glass or large piece of glass. So whereas refractive index is an intensive property which depend upon the nature of the substance, but not upon the amount of the substance, but mass, then volume, these are the properties which depend upon the amount of the substance. So hence we will have to ask ourselves that if I change its amount, suppose we have a small mug of water, and that water will have some density. Now if you take a large drum of same water, will the density change or will it remain the same?
Sir, remain the same.
It will remain the same because it's the same water, and density is something which does not depend upon quantity of water you are taking or quantity of any solution you are taking. It will remain the same. So density is another such factor which does not depend upon the amount. So intensive properties are those properties which do not depend upon the quantity or size of the matter. The properties which do not depend upon the properties which do not depend upon the quantity or amount of matter. Quantity or amount of matter. So what does it depend upon? It depends upon the nature of the substance taken. Are called intensive properties. The properties which do not depend upon the quantity or amount of matter are called intensive properties. So let us try to understand that what are those properties which do not depend upon the amount. Temperature. Temperature. So temperature is independent of the amount of the substance. Density. Concentration. Concentration. Viscosity. Refractive index. So all these properties you will see that they are independent of the amount of the substance. তুমি কিমান খিনি বস্তু লৈছা এটাৰ ওপৰত ডিপেন্ড নকৰে। তুমি কম বস্তু ললেও same value পাবা, বেছি ললেও of the same substance হ'ব লাগিব, you will get the same property. But those properties which depend upon the amount of substance are called extensive properties. Just imagine আমি যেতিয়া বজাৰলৈ যাওঁ to do marketing, the cost of the things that we buy is intensive or extensive?
Sir, it depends on the amount of things we buy.
No, whatever you buy, does it ever happen that no matter whatever amount you are buying, the cost will remain the same?
No.
No.
No, sir.
That means what? It depends upon the amount, isn't it? তুমি কিমানখিনি বস্তু লৈছা তাৰ ওপৰত ডিপেন্ড কৰিব, নহলে তো দোকানদাৰ একদম অৱস্থা বেয়া হৈ যাব তাৰ। তুমি এটা বস্তু ললেও যদি একেটাই দাম থাকে আৰু 10টা ললেও সেম দাম থাকে, তো obviously it's not going to work for that particular person. So whatever commodities we buy, that is amount dependent. আমি কিমানখিনি লৈছো তাৰ ওপৰত ডিপেন্ড কৰে। So thus we can say that extensive properties are the properties which depend upon the quantity or amount of matter. Though price of a commodity is not thermodynamic properties, just for the sake of understanding, I gave you an example. The properties which depend upon the quantity or amount of matter are called extensive properties. So thermodynamic sort, as for example, mass whole, volume whole, these are normal terms, but in the next coming days, all the properties, thermodynamic properties that we will be coming across are found to be completely extensive. Number of moles depends upon the amount of substance. Internal energy change, we'll discuss about it in details later on, but for the timing you simply remember it is denoted by delta U. Enthalpy change, denoted by delta S, delta H, sorry. Enthalpy change, entropy change, delta S, Gibbs free energy change, all these are the terms that we are going to discuss as we will proceed. But for the timing, remember that all these thermodynamic functions are referred to as extensive properties. So it is like saying that if in a particular reaction something is burning, and during this burning process there is release of energy. Now if the same substance is doubled, then obviously the amount of energy that will be released will also be getting doubled. So all these properties like enthalpy change, internal energy change, they will be what kind of properties? They will all be extensive properties. Is it understood?
Oh, sir.
So write it down up to this much so that we can proceed further. Because today's class, we will be mainly focusing on these terms. All these terms are very important for us to understand. Without terminologies, generally we do not give importance to definitions. But let me tell you that definitions play a very important role to understand any topic. Because if the definitions are clear, then only it will be giving us a better understanding regarding any topic. So when I say extensive properties, you must be aware of what exactly is extensive. That means those properties which depend upon the amount of substance. If the amount changes, these properties will also change. If there is a decrease in the amount, then there will be change in that property. But again, the properties like viscosity. What is viscosity? Can anyone tell me what is viscosity? Viscosity is actually, it is
Sir,
an internal
friction
resistance.
between- Sir, friction between fluid.
So there is an internal resistance to the flow of the liquid, and that exists between the liquid layers, which does not allow the liquids to flow properly. In other words, we can say that if a liquid is highly dense, so obviously its flow will be lesser, and we call that it will be highly viscous. Now, if you take small amount of any liquid and we measure its viscosity, it doesn't matter how much amount you are taking, whether you are taking small amount of liquid or large amount of the same liquid, the viscosity will remain the same. Okay. The temperature portion obviously will not depend upon amount of substance. It will be independent of amount of substance. Now, when you are given any property and you are asked that exactly what kind of property it is, how to judge it, how to find it out, the simple way, just ask yourself that whether the property asked to you is additive in nature or not. If it is not additive in nature, then it will be intensive. Now, what's the meaning of the term additive in nature? So let me give you an example. Suppose you are asked that what kind of property is temperature. So what will I do? I'll imagine that suppose there are two bodies, one of which has got 20 degrees Celsius and the other is at 50 degrees Celsius. I mix them up. Now, after mixing them up, the resulting body, will it have 70 degrees Celsius temperature? What do you think?
No, sir.
Obviously not, because the temperature of the mixed body will be somewhere in between 20 and 50. So it is non-additive in nature. So because it is non-additive, the temperature will be an intensive property. Is it clear?
Yes, sir.
Sir.
But when we talk about mass of the substance, so say it is 2 kg, this is 5 kg. So when we mix them up, will it not be 7 kg?
Yes, sir.
Yes. Okay. So if you can add up the quantities, it is additive in nature, then we can say it is extensive. But if you cannot, then they will be intensive. So this will be an easier way to understand actually. So those properties which depend upon the amount of substance are additive in nature. When you mix up the substances, all these properties will also get added up. Okay, irrespective of the nature of the substance. So hence they are called extensive properties. So all the properties that we will be discussing, okay, so ultimately will be correlated with the thermodynamical properties. So yaat ami jikhini discuss korisu, eta bostu ami gom palu je thermodynamic properties, what are the terms involved, like internal energy change, enthalpy change, entropy change, and Gibbs free energy change. All these properties are thermodynamic properties. So we have learned that the thermodynamic properties are extensive properties, which means that they depend upon the amount of the substance. They are amount dependent. They are not nature dependent. After this, we talk about state of a system. So write down the next topic as state of a system. State of a system. So if we talk about the values of macroscopic properties, what is macroscopic properties? Already we have discussed properties of a bulk substance, the substances in large number. If the values of macroscopic properties, whatever properties we study, do not change with time, okay, and are definite, then the system will be said to be in a definite state. So there will be no change. And like pressure, volume, temperature, amount. These are called state variables. Okay, so pressure, temperature, volume, number of moles, all these are referred to as state variables. So they define a state. Now, during any process, if they do not change, so what we say? We say that they have a definite state. But during the process, if there is a change going on, okay, if there is a change going on, so we say that some external factor has come in, because of which there has been some change in any one of them, not all of them at a time. And we have seen in ideal gas equation, Boyle's law, Charles' law, that some parameters were getting changed and some parameters were definite. Definite means constant. So during this change, if we look at the process, the whole process, suppose we have the state variables P1, V1 and T1, which is getting converted to P2, V2 and T2. So obviously, during this process, there is a change going on. The state variables are undergoing change through a particular path. Okay, there is a pathway. There are a number of steps involved. And during this pathway, when we talk about the changes going on, so let us say it is the path going on. And the same change can occur via this path as well. Now, there are certain functions which do not depend upon the path taken. No matter whether you take this path or whether you take this path, the change is same. So such kind of functions are referred to as, remember, state functions. State functions. But if they are path dependent, they depend upon the path taken, not upon the initial and final state, then they are referred to as a path function. Can I get bujao? At a simple example, no? Suppose a person wants to get to the top floor of the building. And there are two options. One is lift and other is staircase. If this person takes lift, so obviously he has to perform lesser amount of work and it will be easier for him to reach to the top floor. So therefore, we can say that the work done by this person is path dependent. Path dependent. If he takes the staircase, he will be performing more work. If he takes the lift, he will be performing lesser work. And therefore, we can say that work done by the person will be path dependent. But after this person reaches at this particular floor, so from the ground, he has got some height. And there is a particular term called potential energy. All of you are familiar with potential energy. So potential energy is mgh, isn't it?
Yes, sir.
Yes, sir.
Okay. Now, if I ask you that what will be the potential energy of the person, will it be same or will it be different when he takes the staircase or the lift? The answer is, obviously the height is independent of how he has reached there, isn't it?
Yes,
He
sir.
keneke aise tar upor depend nokore. Staircase loleu tar etu height hobo, lift loleu tar etu height hobo. So potential energy is independent of the path taken. Are you getting me?
Yes, sir.
So hence, if a function is independent of the path taken, no matter whatever be the path you are taking, but it depends only upon the initial state and final state, then it will be called as state function. But if it depends upon the path taken, okay, so if you change the path, you will get a different result. So then that is called a path dependent or path function. Suppose you call a cab, you want to go to the airport. Now there are two types of cabs. One cab has a fixed rate. According to whom, no matter whatever be the path he will be taking, your rate will be fixed. They will be charging you rupees say 500. Now they can take you via Jhalukbari, okay, from Pan Bazar to you can say Pan Bazar to Fancy Bazar via Jhalukbari, then to airport. There is another pathway. He can take the national highway path, isn't it? But ultimate destination of that particular driver will be the airport. Now, before getting in, if you talk to him that I want to go to the airport, how much you are going to charge me? And he says that I'll charge you rupees 500 no matter whatever pathway I will be taking. So that rate is fixed. So that depends only upon initial and final state. Your initial point where from you are starting to that of the airport. But if you board Uber or Ola or whatever taxis, so they are not dependent on the destination. They are dependent on the path taken. And if they take a longer route, you will have to pay them more. If you take a shorter route, you have to pay them less, isn't it? So this way, we can say that if during any particular process, the initial and final states are important, not the path taken, it will be called as a state function. But when the path becomes important and with the change of the path, the result changes, then that will be called path functions. So the question arises, what are thermodynamic parameters? What are thermodynamic functions? Are they state functions or they are path functions? Like internal energy change, enthalpy change, these four you have to focus upon, entropy change and Gibbs free energy change. So remember, all these are state functions. Enthalpy change qua, internal energy change qua, entropy change qua, Gibbs energy change qua, all of them do not depend upon the path taken. What do they depend upon? Where from they are starting and where to they are ending up. And that is why they are called state functions. So we learned two important things about the thermodynamic properties. Property number one, they are extensive properties. That means they depend upon the amount of substance. And property number two, they do not depend upon how the final state is achieved. Okay, independent of the path. So what is important for them is the initial and final states. They do not depend upon the path taken. Is it clear up to this much?
Yes, sir.
Yes, sir.
Oh,
Okay.
sir.
Now write it down, whatever I have explained. If the values of macroscopic properties do not change with time, the properties are said to be in definite state. The properties are said to be in a definite state. The macroscopic properties of a gas the macroscopic properties of gas, that is pressure, volume, temperature, and number of moles. Okay, already done in states of matter. These are the 4 important properties, are also called state variables, are also called state variables or state functions. State variables or state functions, as they depend only upon the initial and final states. Korpra arambho hoise, koloike goise, that is important. But not upon the path taken. Pathar upor depend kore, but not upon the path taken. Internal energy change, that we have just now discussed, delta U. We have not discussed it, but we have got it as example. Enthalpy change, delta H. Entropy change, delta S. And Gibbs free energy change. And Gibbs free energy change delta G are all state functions. Are all state functions. That means they depend upon the initial and final states, where from you are starting and where you are ending up. These 2 points are only important. How you are achieving the final point, that is not important. So they are path independent. However, if the functions depend upon the path taken, they are path functions. As for example, work done, heat, etc. So what is more important for us is the thermodynamic functions. So if you look at the thermodynamic functions, so we see that they all are extensive properties as well as they are path functions. Quickly do it. so that we can proceed to the next topic. Okay, can I proceed?
Yes, sir.
Yes, sir.
Oh. So after discussion of the state function and path functions, we now move on to types of processes. That means thermodynamic processes. Again and again, I need not repeat that we are restricted to thermodynamics only, because processes as such in this universe are so many. It will not be possible to discuss about all the processes at one go. But here the type of processes that we will be focusing upon will be the thermodynamic processes. So likha types of thermodynamic processes. Types of thermodynamic processes. So it is not very easy. It's not very difficult, sorry, to understand. Some of them you can easily make from their names. Isothermal process. Now, if you carry out any process keeping the temperature constant, so that there is no change in the temperature all through, then the process will be called as isothermal process. Okay, so most of the reactions, chemical reactions, which need to be maintained at a particular temperature are referred to as isothermal process. And how you are going to regulate the temperature? There are certain instruments called thermostat, which has regulator in it. Just like in fan, we have got regulator, we can control the speed of the fan. So in the similar way, there is an instrument called thermostat, where I can increase or decrease the temperature. So when the process is carried out at constant temperature, it is referred to as isothermal process, and the system may be open. That means what? There can be exchange of heat from the system to surrounding. There is no restriction in that. But what should remain same is the temperature. Now, if you are carrying out a process by regulating the temperature and you are keeping the system closed or isolated, the temperature inside will keep on increasing. And therefore, so that the temperature is kept constant, I'll have to carry out this process in open system. And hence we can say that such processes are carried out at constant temperature. So that there is no change in the temperature, the delta T will become 0. Delta means change, T means temperature. So change in the temperature should not be there, and that is why we write delta T is equal to 0. Such processes are carried out at constant temperature. They are usually carried out in open system. And in open system, as you know, that both matter as well as energy can be exchanged with the surroundings. So this is isothermal. Next, we'll talk about isobaric process. Bar is unit of pressure. And when I use the term isobaric, iso means same. So if the reaction is carried out or process is carried out under constant pressure, under constant atmospheric pressure. So for that also, we can have an open system, because when the vessel is open, whatever reactants or the process is going on, it will be under constant atmospheric pressure. It will be isobaric process. Such processes are carried out at constant pressure. So if you carry out any process, there may be change in the temperature. Change in temperature is allowed, but what is not allowed is pressure should not change. And for that, it should be under constant atmospheric pressure. Third is isochoric process, where change of volume is not allowed. And if change of volume is not allowed, it has to be a closed system or isolated system, because only in closed system or isolated system the volume remains fixed. So such processes are carried out at constant volume. Okay, so there should not be any change in the volume. The volume should remain the same. So pressure, volume, and temperature, these are the three parameters, the three state variables associated with gases. So thermodynamics, generally we will deal with gas only, but one more process is there which you should be aware of. It is called adiabatic process, where change in heat is not allowed. There should not be any exchange of heat from system to surrounding, but temperature change may happen. So isothermal and adiabatic are just the reverse of each other or opposite to each other. Such processes are carried out in isolated system, because isolated system is the only system where no exchange of heat from, but it's better to write heat between system and surroundings is allowed. So isothermal or heat exchange is allowed. Temperature should not change. And adiabatic or heat exchange is not allowed, but temperature may change. That is the basic difference between adiabatic and isothermal process. I hope it is clear up to this much.
Yes,
Yes,
sir.
sir.
So isothermal, isobaric, and isochoric are not very difficult to understand. Adiabatic, what you need to make the thing constant is important. So adiabatic or heat exchange is not allowed. Temperature may change. Now you might ask me that if heat is not exchanged, how can the temperature change? Because the heat may be utilized in the reaction going inside. It may be endothermic, it may be exothermic. If it is endothermic, heat will be absorbed and temperature will drop down. If it is exothermic, heat will be released, because it is not allowed to go out of the system, and therefore there may be change in the temperature within the system. One more process you write down, cyclic process. Cyclic process. So as the name implies, if a process is being carried out in several steps, but ultimately it comes back to the original state. then it is referred to as a cyclic process. Say, for example, the state variables initially was P1, V1, T1. They are changed to P2, V2, T2. Again, they are changed to P3, V3, T3. And finally, they get back to P1, V1, and T1. So the process will be called cyclic. Cycle, you know what is a cycle? When you are reverting back to the original situation, original position. So that is called a cycle. So similarly, during any process, if you get back the original conditions by going through several steps, you are undergoing change. I don't say that you are not undergoing any change. Otherwise, you cannot call it to be a process, because in order to carry out a process, change must occur. But here, in spite of having changes, you are getting back to the original situation. When a system undergoes change in a number of steps, but what is important is finally it returns to its initial state. Arambhonik ji state asil hetuke ako jetia ghurai pabo, initial state, it is a cyclic process. It is a cyclic process. I hope the processes are equal, are understood.
Yes, sir.
Okay.
Sir.
So today we have come across all the definitions involved in the chapter of thermodynamics, and slowly we will be getting into the mathematical aspect, and the next class we are going to discuss mainly about the heat and work, which just now we have discussed are what kind of functions. They are path functions. They depend upon the path taken, not upon the initial and final states. And some of the topics you will see is common in between physics and chemistry under thermodynamics. But after discussion of that, we will be going to a special branch of thermodynamics, which is associated with chemical reactions. So when we study thermodynamics in chemical reactions, so that branch of chemistry is called thermochemistry, which you are not going to get again in physics. It is purely the area of chemistry. So when chemical reactions, when thermodynamics is studied for chemical reactions specifically, those will be called as thermochemistry. So thank you. Next day, we will further proceed with the next topic of thermodynamics.
Thank
Good
you,
night.
sir.
Thank you, sir.
Thank you, sir.
Yes, sir.
Thank you,